Properties of congruences. Before we tackle about the properties of congruences, let us first define what is congruence. Definition: A is congruent to B modulo M, or in symbols, A congruent to B modulo M if and only if M divides A minus B. Example, 720 is congruent to 0 modulo 10. By definition, M divides A minus B, so M is 10, A is 720, B is 0, so 10 divides 720 minus 0, and 720 minus 0 is 720, so 10 divides 720. Now we can find a number that can be multiplied to 10 that is equal to 720, and that is 72, so the statement is true. Now, let's proceed to the properties of congruences. Property number 1. A is congruent to A modulo M, where M is greater than 0. Reflexive property. Proof. Suppose A is congruent to A modulo M. By definition of congruences, M divides A minus B. Then, A minus A is equals to 0. M divides 0. And we can find a number that will be multiplied to M that is equal to 0, and that is 0, where M is greater than 0. Therefore, A is congruent to A modulo M. The statement is true. Example, 5 is congruent to 5 modulo 4. By definition, M divides A minus B. So M is 4, A is 5, and B is also 5. So 4 divides 5 minus 5, and 5 minus 5 is 0, so 4 divides 0, and we can find a number that can be multiplied to 4 that is equal to 0, and that is 0. So the statement is true. Second property. If A is congruent to B modulo M, then B is congruent to A modulo M, where M is greater than 0. Symmetric property. Proof. Suppose A is congruent to B modulo M. By definition, M divides A minus B. This means A minus B is equals to K times M, where K is an integer. Now we can factor out negative 1. So, B minus A is equals to Km. Divide both sides by negative 1. The result is B minus A is equals to negative K times M, where negative K is an integer. Now, B is congruent to A modulo M. The statement is true. Example, let A is 6 and B is 3. 6 is congruent to 3 modulo 3. M divides A minus B. So, 3 divides 6 minus 3, and 3 divides 3. We can find a number that can be multiplied to 3 that is equal to 3, and that is 1. That is for A is congruent to B modulo M. For B is congruent to A modulo M. So 3 is congruent to 6 modulo 3. M divides A minus B. So 3 divides 3 minus 6. And 3 minus 6 is negative 3. So 3 divides negative 3. And we can find a number that can be multiplied to 3 that is equal to negative 3, and that is negative 1. Property number 3. If A is congruent to B mod M and B is congruent to C modulo M, then A is congruent to C modulo M, where M is greater than 0. Transitive property. Proof. If A is congruent to B modulo M and B is congruent to C modulo M, then M divides A minus B and M divides B minus C. Using the linear combination theorem, M divides A minus B plus B minus C, or M divides A minus C, thus A is congruent to C modulo M. Therefore, the statement is true. Example, let A is 5, B is 8, and C is 11. 5 is congruent to 8 modulo 3, so M divides A minus B, so 3 divides 5 minus 8, and 3 divides negative 3, and we can find a number that can be multiplied to 3 is equals to negative 3, and that is negative 1. So, that is for A is congruent to B modulo M. So, for B is congruent to C modulo M, 8 is congruent to 11 modulo 3. M divides A minus B. Thus, 3 divides 8 minus 11, and that is 3 divides negative 3. And we can find a number that can be multiplied to 3, and that is equal to negative 3, and that is negative 1. So for A is congruent to C modulo M, so 5 is congruent to 11 modulo 3, and that is M divides A minus B. So 3 divides 5 minus 11 is equals to 3 divides negative 6, and we can find a number that can be multiplied to 3, and that is equals to negative 6, and that is negative 2. Therefore, the statement is true.